back-to-back meetings through the day. I wish I had coffee. Let me open Blinkit. 9 minutes. That's how long it takes for somebody to receive a signal, go into a store, find the item, pack it, give it to a rider who comes and delivers it. Wow, that sounds like magic. Let me unpack the tech stack of the $10 billion quick commerce giant. Let's dive in. First, you have to understand the physics. Traditional e-commerce like Amazon and Flipkart operate on a hub-and-spoke model, which involves giant 200,000 square foot warehouses 50 kilometers outside the city. That's why you wait for a day or two. Blinkit destroys this model. They don't see the city as a map. They see it as a mesh of polygons. They divide the entire city into small geometric zones, and each polygon has a strict rule. The delivery time from the center to the extreme edge cannot exceed 10 minutes. Here's the growth hack. If demand in a polygon rises and delivery time slipped to 12 minutes, they don't just hire more drivers. They physically split the polygon in half and open a new dark store in the new zone. Cellular mitosis, but for logistics. Now let's talk about the mode, the dark store. Blinkit has over 60 of these in Bangalore alone. These aren't warehouses. They're 2,000 square foot micro fulfillment centers. That's the size of a large 3-bedroom apartment. Inside, they hold 6,000 SKUs, but unlike Amazon, which uses robots, Blinkit uses muscle memory. Because the space is so small and the clock is ticking, robots are actually too slow. A human picker knows exactly where the items are. They use an algorithm called FIFO, first expired, first out. The app directs the picker to grab the items that expire soonest, ensuring efficiency and reducing waste. The picker packs this in under 60 seconds. But how do they hold inventory for hundreds of stores? This is where the mother warehouse comes in. For every 40 to 50 dark stores, there's one massive mother warehouse, which is about 150,000 square foot. The mother feeds the kids. They use predictive AI to restock the dark stores every night based on what you're going to order the next day. Okay, that's the physical layer. Now let's look at the software layer. How do you handle 50,000 requests per second without the servers catching on fire? Well, Blinkit isn't a monolith. It's a distributed system running on microservices like Java, Go, and Python, everything orchestrated by Kubernetes. But here's the hardest problem in quick commerce. It's not delivery, it's concurrency. Imagine there is exactly one packet of blue Lay's chips left in the dark store, and me and my neighbor Rahul both hit pay at the exact same millisecond. Who gets it? If you use a standard SQL database, both payments might go through, but there's only one bag. One of us is going to be very angry and hungry. To solve this, they use Redis. Redis is an in-memory data store. It lives in RAM and operates in microseconds. They use distributed locking, and the moment I hit checkout, the system pings Redis, puts a mutex lock on a specific item for 3 minutes. Even if the main database hasn't been updated yet, Redis knows that the bag is locked. Optimistic locking at scale. Next, the data pipe. You can't run a 10-minute business if your data takes 2 hours to arrive. That's like driving a Ferrari using a map from 1995. Blinkit uses Apache Kafka. It's the central nervous system. Rider location, Kafka stream. Inventory update, Kafka stream. Rains in Koramangala, Kafka stream. Speaking of rain, they don't just trust Google Maps either. They use Zomato's weather infrastructure called Weather Union. If it starts raining in just one polygon, the system knows before Google does. The algorithm instantly adds a rain buffer to the ETA and surges the price to balance demand. And they use S2 geometry by Google Maps, where they divide the world into mathematical cells to calculate time to park, time to climb stairs, etc. Yes, they do track how long it takes to go up the elevator. Finally, the prediction layer. Blinkit uses gradient boosting machines and neural networks to predict the future. They call this the slot intelligence. The model looks at weird inputs. Is it raining? Demand for tea goes up 300%. Is it an India versus Pakistan cricket match? Demand for chips and Coke spikes. Is it Valentine's Day? Flowers move to the front of the store. The AI predicts the surge before even it happens. If the model sees a storm coming, it tells the mother warehouse to send extra onions to the dark store. By the time you open the app to order soup, the onions are already there. Amazon reacts to your order. Blinkit anticipates it. They also use a brilliant piece of psychological engineering. Notice that when the rider is about 100 meters away, the map stops showing the time and just says, arriving soon. That is a UI hack. GPS is jittery at the last 100 meters. If the dot jumps around, you get anxious. By switching to text, they buy the rider a 30-second buffer to find your door without you panicking. All of this, the microservices, the Redis locking, the S2 geometry, the neural nets, all has to execute in under 200 milliseconds. If the latency is higher than that, the app feels sluggish, and then you go to Zepto or Instamart. But Blinkit algorithm works. While I enjoy my cold brew, follow Hackonomics for more such interesting insights.